show you
You're the telecom guy and the electrical guy.
efficiency.
Well,
You're out? Yeah, not again.
No, well,
They know where the printed circuit board is, so. Yeah, so I'm Gordon. I'm Tim. And then Alan. This is our project here. This is our facility factory. Essentially, start to finish, create a ready to solder and ready to put parts on efficiency. So on the agenda today, we're going to talk about the problems that we're trying to address. We want to be able to address that problem, what our solution actually is, and then workflows.
That's why I like presenting the same thing, because I just give you some
Problem that we encountered is a fairly large group of hobbyists or academics that are trying to create small circuit boards.
Stand in front. I'm going to send a photo of
Electronics. It's fairly difficult for them to find different methods of making it, iterating different what they may need for efficiency. You guys know what a printed circuit board is? It's essentially in this case, fiberglass covered with a very thin layer of copper that is being cut out or traced in the exact images they need for. Did you check around this?
So, okay, do you notice it?
Yeah.
Spaceship. It's pretty punchy. So when I was doing this,
Actually use
this is from a different lighting. This is from this. Do I try to color correct it?
That was
Why didn't you just-
one of the main
This doesn't
starting
have-
points in this project.
Color.
The process typically for manual
But you
production
can-
is you need to mask the blank board. You're then going to etch out.
No, you can copy it in paint, get the hexadecimal,
I did it.
move it over.
I put it into a
Yeah, no, I do know.
Available options for making
You know what?
I don't like the pixel ratio that they have.
Yeah, so
manual production method, which I discussed.
It's been like that.
as a companies,
I know.
We have a minimum
Like, cause that wasn't bad.
but I like the idea of these. And it's because we don't choose to use them.
China shipping. So very big impact on the environment, obviously, and with the minimum orders, if you're iterating and you don't know whether your circuits actually work, you want to make different iterations. If you order 50 of them, it doesn't work. Now you got 49 sitting on the shelf. Next option available for actual machines. There's two different types of machines that can be found online. There's the CNC type machines and a printable conductive ink printed version. The CNC machines are actually going to remove copper. They're fairly destructive on boards. They make super big traces that you want detailed quantities. The printable
Instead of engineering, paving the way to a
modules have fairly high accuracy on them, but you have high resistivity and high impedance on the actual board itself. So if you're using a low voltage circuit, they're definitely not ideal.
Brings us to our sending on the device, so automate all the steps, mask, well, not each way to mask for the fixture. And we'll run the path, we create the panel for you. We have the path that goes on fire, we're prioritizing ease of use. So we want people that are familiar with 3D printers already. They can come in and use this machine. It uses mostly open source like concepts for the software, the interface. But prioritizing ease of use essentially. Easy touchscreen, and we have low tooling loads because we're just taking off heat coated paint. So we can make much cleaner lines, like cleaner traces, as opposed to the CNC routing option. And then as far as the surface mesh is just allows us to use, which is like we'll talk about it more, but the BL Touch allows us to mask or mesh the surface of the board, which allows us to use much more economical boards because they're not all flat. There's quite a bit of imperfections that go along with getting a bunch of cheap circuit boards. which is very difficult to adjust Z height for. And then as far as the innovative etching chamber that we've 3D printed for this design, we would do it differently for design for manufacture, but in our case this is perfect. We've integrated the fixture alongside with the etching tank itself. So keeping the board in the fixture with an easy cam lock process. Yeah, so it just has a simple 2 little cam locks that twist it and hold the board in place, which allows us to retain our coordinate system for to run the entire process. As far as that, we have also 3D printed a gasket as well, which goes underneath the lid and carries the manifold on it that will help place on top, easy Tupperware kind of style latch, and we would run our etching process and complete the etching process to take the copper traces away after exposing the copper traces. As far as the tool design, the tool carriage, it's also another custom design that we did to incorporate just a conventional CNC router and engraver motor and a universal E11 collet chuck, which can be used for generic hardware, as in or in this case an 1/8 inch engraving bit, or the drill bit you need for whatever component you're going to install in the final product. It also allows us to incorporate that BL Touch, which is the method we ended up going in the end for the masking. The meshing of the top of the CNC. And then as far as you can see on the top there, this is something one of the first methods we went for a conductive method, where we have, so there's a brush that runs on top of the spindle of the CNC motor, and then our original plan was to have a wire going through the board, and then when the bit made contact with the copper, it would complete the circuit and pause the Z height, essentially. But it was not reliable, unfortunately.
Too much vibration in the system to really be accurate.
Yeah, so we ended up placing a lot of then you can kind of see more accurately the different components involved. Oh, sorry, and the vacuum nozzle is all for scavenging all the drill debris. That's what this Scorpion style vacuum nozzle. And then we've incorporated a peristaltic pump for running the etching because it's primarily because it's not in contact with the etching. So it's just it's simple, it can be run dry, and it's also easily reversible. And so the whole pumping operation can be done with a macro and the human interface all in one go. So go clean the lines, and then it's just a quick, so you can suck the lines dry, quick little wipe job, and you're ready to drill the switch for the drill to drill your hole. Oh yeah, and then obviously the supporting base is very stable base. We would do it differently if we were doing it for a more professional standard, I guess, but this is just proof of concept for now. Yeah. As you can see, And then we have Alan with the financials.
Yeah, so at the end of the whole project, we pretty much ended up spending around $1,500 reconverting the 3D printer that we initially started with. So the printer itself was around $700 US, and an additional $1,500 between cost of tools, trial and error of the conductive method for the meshing system and other systems and little mistakes we were doing on the road. It was our capstone, so we were trying pretty much to see what was fitting and what we liked, and see what was also doable on the software with the board we have. In the end, it costed around $1,500. Our project, our aim would be at some point to make it produce it in mass scale. So as 3D printers started really small in a really niche category, expand to as many people as possible, and cut down costs, because the more pieces you buy, obviously the less you spend per unit of the item you're buying. So yes, for now we 3D printed a lot of our parts. A lot of them, as the bed as an example, could be plastic formed, hot formed. So cuts down the time of production for sure, and scales the unit of production too by a lot. And also we probably have to try to compact this whole system in a more user-friendly and probably more desk size probably item. So it's a little less aggressive to the eye for sure. But yeah, so our project is to expand and to for sure make it more user-friendly than it already is. So it can be accessible for, the people who already are in this world, but also to try and get people that are not interested today, but maybe would benefit from the printed circuit boards world, which are a bigger and bigger realm.
I'll just go through the workflow of actually setting up a job and getting the machine running. We try to make it as simple as possible, so we took some of the open source methods that were available and just try to optimize and put together a package that was just really easy to use. So in our case, we used Fusion 360 to create the circuit itself, and I'll put a Gerber file which has all the traces and hole patterns, uploaded that into FlatCam, which is pretty much the only free software that you can use to get, that I was able to find to convert to Gerber files into G code. It's quite limited in what it can do, but it's actually pretty powerful and what it does do well. Unfortunately, it only outputs a single G code pattern for each isolation trace, and since you want to run typically 2 to 3 to make sure that you get all of the isolation paths cut, I wrote a simple C program that just takes all of the movement files, puts them in a single block, preserving just one header and an ending file per block to set up the machine and finish the job. After that, we load this PCB blank into the machine as I demonstrated earlier, where you just open up the cam lock, slide the slider back, put the board in, pull the sliders forward, and then just with one hand clamp those down and it locks it in place. Since the machine has such low tool loads, it really doesn't take a lot of clamping force to hold it in place. After that, you simply you open up the dashboard. Here. So this is the web interface dashboard that comes with the Juliet Wi-Fi controller. So it creates a web page. It's accessible on laptop, cell phone. It's really easy to use. You simply just push the upload and start to run any of the G-code programs, and it runs the whole cycle. At the end of the isolation programs, it parks the machine up at the top, so you can just snap the lid on top, hit the pump and run macro either from here or on the touchscreen interface there. Just do them. It also has the macros, and you could also upload through that. So from there, you run the etching cycle. It pumps for about 5 to 10 minutes. Actually, in certain cases with really thin boards, you can do it in as little as 3 minutes, but we have all of that automated. So it's just a single press, runs the pumping cycle, backflows to drain the lines, and then just pop the lid off. Even while that's running, you can put in your first drill bit and get that all set up. So as soon as the etching's done, you just simply run the G-code file for the drilling process, and it has all the coordinate system currently mapped, so nothing's been lost, and just accurately drills all the holes right in place. After that, it's just a simple matter of giving it a quick wipe and a rinse. We use acetone to remove the paint to expose the solder pads, and then just populate and solder the board. All in all, it takes about 45 minutes start to finish, from outputting from a Fusion file to having a board ready to assemble. So I'll go back.
I don't know if you want to see the boards.
Some of our practice boards, we were setting up the machine and kind of what it was capable of.
The machine where you see it's gone too deep, which is definitely a problem that we've had access with.
Well, then I'll carry.
This one, it's hard to see with the light. Like, it had light behind it. You can see the holes have been drilled.
Yeah, if you hold it up to the light, it's kind of see through where the drill holes are. And yeah, one of the things we still kind of need to work on is getting an accurate measure of where the tool is on the bed. Yeah, that's kind of a finished product with all the paint. Getting the Z axis, because it is pretty finicky.
Right.
One of the things I noticed during setting it up over the summer was that you can really hear it properly during putting a vibration sensor on the tool head to detect when that optimal frequency is. Yeah, because you can kind of see it.
It loses a little bit of the traction.
And with these inexpensive boards, it's like a lot of these come out really curved. They're not at all flat, which is one of the shortcomings of the CNC machines that are available now, is that they don't have any surface mapping, and you have to be really flat and level. They kind of rely on you using the machine itself to flatten everything. And
It's not the quality you need to
yeah.
outside of this.
Exactly. Right. So this cuts to when I was kind of fumbling around learning the Turner transfer method. It took me 4 hours to a couple of days to really get a single board made. And this, like I said, you can iterate and even just pump a few out in very little time.
And you can imagine drilling all these manually. Is,
You've probably done it yourself.
yeah, it's a bit of a nuisance.
Yeah, having to see it, like, even just having this set up as a drilling rig is like a game changer.
Yeah, it's a dual purpose.
Yeah, so yeah, that's pretty much our presentation. And I'd like to answer any questions you have.
I have one because mine will be. I think you covered with the dry pump you covered it because that was going to be my first trying to get you on that. What maintenance considerations are there? So you have the etching fluid draining.
Yes.
You know, I see you got contacts or stuff like that. So what all goes in that an end user? Let's assume it's a hobbyist, so they don't know what they know. What have you thought about that at all?
Yes, yeah, for sure. Actually, we were thinking about doing like a two-way kind of switching valve, so you can actually run like a water or like some kind of neutralizing solution through it. That way you can get rid of all the etching remaining in the tank, and then you won't have any kind of corrosive, not such a corrosive environment in the top. So as you can see, like even from our CNC engraver, it just being in that enclosure over the summer by itself, it got like it corroded.
Fumes corroded.
It fuses up.
All the metal that was.
Yeah, that's
So if you
probably our
watch-
biggest pitfall right now is
Yeah.
corrosion, just from being in proximity to tension. It doesn't seem terribly difficult to solve, but it's something we didn't really consider.
lie.
Yeah.
I got you.
Yeah. So essentially, maybe two reservoirs, one of like a neutralizing solution, one of the etchant, and maybe a two-way switching valve. You could just easily put it. You can include it in the macro. Like, essentially.
So that's really it, other than bits, the mechanical pieces.
Yeah, just keeping all the mechanical components lubricated. It's pretty standard, like the same kind of maintenance as a 3D printer, except you don't have a nozzle with the planes.
So in terms of like, again, so if we're gonna mass produce it, is there anything that's incredibly unique compared to like a 3D printer in terms of like the modular pieces and they build it and whatever, or is there somewhere you can see a hang up in mass producing this currently?
We probably want to figure out some sort of solution to make the vise a little more reliably without a 3D printer. It's kind of stylized off of an extrusion, so that wouldn't be terribly difficult to have just custom extrusion lengths made and then just quick CNC machine any features that we need in them.
Probably the Z leveling is.
And then the Z level
Is our biggest
Yeah.
concern at the moment. That will be the first thing we want to tackle when we get back on it.
We've had recommendations for the proximity kind of sensor, like the lasers.
Some were spindles with a spring on it, so it would adapt to the height itself. So
It would actually take care of a lot of that.
But yeah,
the spring probably is one of the greatest idea. We never really looked into it too much. The suggestion came from our professor from our school. Yes,
Cool.
he was really into it too, and
Right,
proposed that. Yeah.
So, but there's not, I mean, there's nothing, I guess what I was getting at, there's nothing unique to this that's not with a regular CNC or 3D.
I'd say the chamber is kind of different from anything I've seen before, like having an integrated fluid bed with the vise in it. Like I haven't really seen that anywhere. So, but otherwise everything else is pretty off the shelf.
So like longevity-wise, that's what you mean, like. Yeah, like how it would react over like a longer period of time.
Yeah,
like
yeah.
tweaks
Well, and
or-
even, well, no, that's right. Like you answered it. It's more just like, it's not that you need to solve every problem. It's
We're
just
not-
that you need
we're
to,
not reinventing
you just need, is regular maintenance enough to keep it working? That's all. Yeah. All right.
Here's my question on the financial side.
Yes.
So, $1,500.
Yes.
I guess this is like a hobbyist who's.
Yes.
How big a market is it? Like if I didn't have one of these $1,500
Yes.
devices in my house, you would go and
So-
like what is
so
what
the
is
different
cost of
options-
getting somebody else to do this for?
So the different options would be to go online, of course. We saw a couple sites that would ship in a couple weeks. So there's a lot of lead time already, which is in some companies or some people that want to get things done pretty quickly, a big issue. And there is a minimum order for pieces and price sometimes. So $100 we said 50 pieces minimum,
Right.
right?
Oh,
So
okay.
we end up with
That's
a
your
lot
year.
of, maybe wrong boards because maybe sometimes we make a little mistake and we want to retweak it or change the position of some of the transistors or whatever other components. So this would make all the steps, if you're making it in 45 minutes, you solder it on, see it's not working, tomorrow morning you could already have a new board and solder it on again.
If you're even so I've done this and I've
Yeah.
looked into doing it myself. I think if you're even thinking about being in that world, you realize that this kind of quickly makes sense because the alternatives are, yeah, like you said, the mass producing, you blow that alternative out of the water. It's more like you have the etching math and you're drawing them, and then at that point you're limited in the complexity of what you can make. So that's, I get it's a good question because if you don't know this world, it's like who's going to buy this? But once you're in that world, it makes sense right away. Because
Also, we're kind of looking at the early adopters of 3D printing, for instance. It was like people that really wanted to tinker and wanted to get into the guts of how everything works. And this just really simplifies getting into that. It opens a lot of doors for people who are curious about it. And have a
Pretty much. Maybe with the 3D printer, you have also this on the side, right?
Yeah.
What we were thinking was making a kit. So instead of buying a new 3D printer or a new machine, you just send the kit with all the components. And so you're repurposing the 3D printer, which maybe you have 2 or 3 of them, because apparently that's what happens when you buy a 3D printer. I don't know, it's a myth that happens.
I don't have one yet.
I had one and then I had 3.
And then we ended up with 3, right?
All my buddies
So maybe,
don't have one.
so this was one of his first 3D printers.
Cool.
This is 3D printers, and he was like, you know what?
You already did.
Let's reuse it, right?
I like the edge. You could sell the edging.
Yeah.
Yeah, just like an add-on kit. Like we said, we started from a Prusa Bear, which is like an open source upgrade to the Prusa Mark III, and we made a couple of subsystems and a handful of printed parts to modify it, and that in itself, I think, would be desired.
What's
I do have to cut off. We're running over time.
Okay.
If you want to come back after.
Yeah, well.
But
Thank you so much. Thank you so much. Nice meeting you. Yeah.
It's not even that bad right now.
Yeah, it is.